All right, so this is more encapsulating, I guess, level 2 university mathematics, so advanced calculus. But I feel like this is a very important concept that we can teach today. So the question reads, how do you convert rectangular coordinates to polar coordinates? So another word for regular coordinates is actually the Cartesian plane. So the Cartesian plane, it runs on x and y or whatever. So there's x and there's y. Okay, so this is what we call the Cartesian plane. So I'm going to write Cartesian. Okay, so this is where our rectangular coordinates exist. For example, if this was x here, so let me use different colors here. If this is x here, and this is the y over here, this resultant point over here is no, sorry. This resultant point here is point xy on the Cartesian plane, or a rectangular coordinate because it makes a rectangle, right? So let's do this. But alternatively, we can think of this rectangular point or this rectangular coordinate as a line from the origin to this point. Draw a line. So there's a line. That's a really bad line. Let me try again. All right, so we can alternatively think this rectangular coordinate as a line from that point to the origin, right? And what we have here is actually, we have a right angle triangle, okay? And we have a few pertinent pieces of information here. First of all, we have an angle theta. And second of all, we have a hypotenuse with magnitude r, okay? So what it means to convert rectangular coordinates to polar coordinates is we want to take our rectangular coordinates and transfer it to a different plane where the units for the x and y axis are instead r and theta. And the r, let me explain here. So r equals the magnitude of the hypotenuse, while theta equals the angle. Okay, so we want to use the values of x and y to convert it into different coordinates with the magnitude of the hypotenuse and the angle, which is theta, right? So how do we convert that, right? So let me take another, and also, so let me get another. Oh, okay. Okay. So let's say that this is our polar coordinate system. Okay. This is our polar coordinate system, and the units for this is r, which is the magnitude, and theta, which is the angle, right? So how could we possibly take our x and y and convert it to r and theta? So let's write this here. Well, if you guys remember your trigonometry, Pythagorean theorem, r is essentially the hypotenuse. The magnitude of a hypotenuse is just the adjacent arm and the opposite arm, or x squared plus y squared square rooted, right? So the magnitude of r is just x squared plus y squared and a square root of that, right? What about the angle, right? What about this angle, right? If you guys remember your sine, cosine, and tangent angles, SOHCAHTOA, so sine is opposite over hypotenuse, cosine angle is adjacent over hypotenuse, and the tangent, or the theta for tangent, is opposite over adjacent. So we're given the opposite, which is x, or sorry, which is, yeah, x, and adjacent, which is y. So theta is actually related by tan of -1, x, oh, opposite over adjacent, over y. Okay, so, sorry, it's y over x. I am y over x. Okay, so our angle is defined as tan -1 or tan inverse of y over x, and our magnitude of our hypotenuse is related to the square root of x squared plus y squared. So now we can convert these xy coordinates into our new polar coordinate system um, where this and this is theta and this is r. And that's how you convert that to the polar coordinates. If you want to convert it back, for example, it's very simple. You just use the equations x equals r cosine theta. Because if you think about it, r cosine theta is adjacent over hypotenuse, right? So to find our x coordinate for our Cartesian plane, we just isolate for x, and for y, it's r times sine theta. So why is this important? So there are certain integrals that you have to calculate maybe in level 2 university mathematics, where actually converting to the polar coordinates is much easier to solve the integral or calculate the integral than to use rectangular coordinates or the Cartesian plane. So that's why it's actually advantageous to use the polar coordinates whenever you can. It's mostly primarily used when you're trying to calculate um, the integral of, I guess, circular objects or uh, a circular space enclosed by two curves or something like that. So, yeah, that's how you convert from the rectangular coordinates to the polar coordinates. So the junior tutor puts a very good description and a very good illustration here, and they also run through how to convert from rectangular to polar. And yeah, this is correct. This is the correct solution. Okay, cool. All right, moving along, we